Hey guys, welcome to my channel Code with Kai, and topic for today is lead code number 34, find first and last position of element in sorted array. So this is video number 13 of binary search playlist. For more beginner content of binary search, you can refer my playlist. So let's get started. So according to the question that we read, if you have an empty array, in that case, and we want to find some target that is 8, that is just not possible. In that case, we are going to return -1 comma -1 as the answer. Okay, and what we the target element exists, in that case we want to return the starting index and ending index of this as the answer. In this case it is 0 as the starting pointer and ending as the ending pointer, so we want to return 0 comma 3 as the answer. What about when the target is 4 and target does not lie in this particular element array? In that case we still want to return -1 comma -1 as the answer. Okay, so let's see how can we solve this question using binary search. So let's get started. So the base intuition for this is very simple. So let's say you find the mid. Okay, you find the mid and you are searching for left. You want to search for the leftmost. When you search for the leftmost, what you will do is, if you find the answer, or if you find the answer on the mid, you're still going to continue the search in the left direction. You're going to continue the search in the left direction. Okay, when you're searching for left and you found the element, you're not going to stop at this point. Okay, generally you will return index on the binary search when the target and the middle element matches. But in this case, you're not going to do this. You're going to say that I will continue the search in the leftmost direction still. Okay, so that is the basic idea. And when you're searching for the rightmost element, in that case you will say that you will search. When you find the element mid, you will still go and check the right indexes. Do we have element as index as the target too? And if that target is the element, then you will store that as the answer. Okay, and you will still, even if after finding this element, you'll still go on the right side. Okay, so that is the base intuition for this. So we require two function calls, that is for the leftmost we want to find, and for the rightmost also we will again perform a binary search. So binary search is going to be called 2 times. Okay, so let's just see how we can implement this, and let's just do a dry run to do how we can find the leftmost and the rightmost part. So we have broken this problem into two sub problems, that is we want to find the leftmost part, and let's say we want to find the rightmost part, and these two are two different problems. Okay, so in the first pass what will we do is we'll call the binary search and it will find the leftmost part. Okay, and we'll call the binary search again, and this time it will find the rightmost part. Okay, so if our target is 2, the leftmost part is 1, so 1 as the answer. And if the target is 2 and what is the rightmost part? The rightmost part is 6, that is the 6th index, so we return 6. So I've already written a typical binary search code that you will see. And in the case when we find the target, if the array of mid and target matches, we are returning mid. Okay, so let's say the starting index was this and the ending index was this, and when we found, let's say we calculate mid now. So this is where we are actually. So let's say mid is equal to s plus e by 2. The answer is going to be 0 plus 6 by 2. So the mid is going to point at 3. Okay, so we went in a while loop, we calculated mid, and we are now going to have this check. So this check is a typical binary search check. If array of mid is target, we want to return mid. But if we return mid, whatever is at the mid, if we return this 3 as the answer, this will not work. This is not the leftmost part, remember. If you want to find the leftmost part, we have to search in the left side even after finding the mid. That is the base intuition for this problem. Okay, so even when I find mid, we are still going to go on the left side. Okay, so if I want to go on the left side, that means this right part, this whole thing should not exist, right? That means I can take the end pointer, whatever the end pointer is where was pointing, and move to mid -1 in that case. So in this case, what I'm going to do is, when array of mid and target matches, in that case I'm going to say end pointer is equal to mid minus 1. Okay, and if that is true, if that much is true, so initially we had some answer, then we found the better answer, right? So we have to keep track of a mid index variable. Let's say idx is equal to -1, and we have to update idx as we find the element. Okay, so the idx will become mid. So let's say I found the mid, when this was the mid it came. So I updated this answer with 3. Then after that, the mid I got was different. So let's just do a dry run to understand it better. So let's say the idx is -1, and for the first time we calculated mid I got was 3. I'm going to compare, is 2 and target same? Okay, so the answer is yes. So the 2 and target are same. In that case, it will go in this particular block. It will set the idx is equal to mid. So the leftmost part I'm saying is, since we want to go left even after finding answer, I'm going to store this index as the answer. So what is my index? My index was -1. I'll update it with this 3. Okay, then I move the ending index to mid -1. So this is where the mid was. I'm going to move it. So this whole right part will be excluded. Okay, now I'll calculate mid again. What is my mid? Mid is going to be s plus e by 2. The answer is going to be 0 plus 2 by 2. The answer is going to be 1. So this is where the mid is pointing now. Okay, again I'm going to compare, is whatever is at mid and my answer matches, whatever is my target matches. The answer is yes. In that case, I still want to update, since this is the leftmost part now, since we went left and we still found the answer, we still found the element which matches the target. In that case, this is the leftmost part, that is what we are saying. Okay, so I'll update this with 1. So this is the index of the mid. Okay, and since I again went in this block, I have to still also go is equal to mid -1. Okay, so again I'm going to say, I'm going to cut the end index and move it to mid -1. So this is where the mid was pointing, mid -1, previous index is going to be 0, and I have to exclude the right side. Okay, now I'm going to calculate mid again. In this case, mid is going to be s plus e by 2. The answer is going to be 0 plus 0 by 2. The answer is going to be 0. So this is where the mid is pointing now. So let me draw the mid, the 0th index. Okay, again I'm going to check, is whatever is at array of mid, that is 1, does it match the target? The answer is no. So this block won't be executed. Okay, and if it doesn't match, it is going to ask if whatever is at array of mid, that is 1 greater than 2. The answer is no. So this block will also not execute. Okay, then it is going to ask, is whatever at then this block will execute. So that means s is equal to mid plus 1. So whatever is at s is pointing, it is going to go to the next block. Okay, so s will point to the next element, that is maybe this is where the s will point. Okay, so s will be moved to this, and as soon as the s and e pointer overlap each other, okay, then at that point binary search is going to stop. So we after the binary search is over, we have answer, that is the leftmost index. We found the leftmost index in the idx. Okay, so the idx is 1 at this point. So that is it for the leftmost side. What about the rightmost side? How can we do it now? How can we solve this for the rightmost side? So the concept is going to be pretty same. So let me erase things out. Okay, so now we want to find out the rightmost element of the target. So what will we do is, we'll again do a binary search on this thing. So let's say the starting index and ending index I have set. I'll calculate mid. What is my mid? My mid is going to be s plus e by 2. It is going to be 0 plus 6 by 2. It is going to be 3. So this is where the mid is pointing. I'll ask the same condition, is whatever is at array of mid, does that equal to the target? That means, is 2 and target same? The answer is yes. So in that case also, what I'm going to do is, I'm going to set whatever I found in the idx. So I'm going to set this in the idx. Idx is equal to mid. And since I want to find the rightmost element, at this point I'm going to have to go right? So I want to go right. In that case, the left side will be excluded. So on left side, I'm not concerned with. So I can take this S pointer and move to mid plus 1. So this is where I can move the S pointer. In that case also. Okay, so I'm going to say the S is equal to mid plus 1. Since I want to find the rightmost element now. Okay, so I can take this S and move it right here. Okay, so this whole left side will be excluded from the binary search. And let's calculate mid again. So my mid is going to be S plus E by 2. It is going to be 4 plus 6 by 2. It is going to be 5. So this is where the mid is pointing. So I'm going to ask the same condition is whatever is at array of mid, that is what array of 5, that is 2. Is 2 and target matching? The answer is yes. In this case also I'm going to say the new index. So the new index I had to update previously. It was 3. And now I have to update it again. That is whatever is at whatever index I got, that is 5. I have to update 5. I'm going to update 5. Okay, then I have to say that S is equal to mid plus 1. I have to take the starting index and move to mid plus 1. So this is where the starting index will go. Okay, and this will exclude the left side now. This will cancel the left side. Now, after this, the starting index and ending index are pointing at same point. So let's calculate mid again. It is equal to S plus E by 2. It is going to be 6 plus 6 by 2. The answer is going to be 6. So this is where the mid is pointing. Again, I'm going to ask the same condition. Is whatever is at mid, is it equal to the target? The answer is yes. Since 2 and 2 matches, at this point, I'm going to say S is equal to mid plus. I'm going to update the index. So what was my IDX? IDX was 5. It will be updated to the latest index, that is going to be 6. And I'm going to say the S is equal to mid plus 1. Whatever is at S is pointing, I'm going to move to mid plus 1. So this was the mid. So it will go out of bound. The S will go out of bound. Okay, and as soon as the S and E does not crosses each other, actually, as soon as the starting index and ending index overlap each other and cross each other, at that time we are going to stop the binary search. Okay, so once we stop the binary search, at that point whatever is at the IDX will be the rightmost element. So let's just go to the coding part of this, how we can solve this and optimize the code for this. So for now I require two functions, as I've seen. The first function is to find the leftmost element and the second function is to find the rightmost element. Okay, so as you can see that if their target exists, we want to return the whatever the answer is, or otherwise we want to return -1 as the answer, right? So what we can do is we can do two function calls, that is for first for finding the leftmost part. Okay, what is the leftmost element, leftmost index, and the second call is for the rightmost index. Okay, so I'm going to have two separate functions. Let's say int, so this is going to be index, find leftmost index. Okay, and the other is going to be find rightmost index. Okay, for the leftmost part, what I'm going to say is I'm going to call the leftmost index function. I'm going to get the left. Okay, and I'm going to call this with nums, target, starting and ending index. And for the right side, this is going to be exactly same. Okay, instead of left, I'm going to call right, and whatever we get as the answer, we're going to return this. So it is going to be left and right. Let's just declare the starting and ending indexes. The ending index is going to be nums, that is going to be nums dot size -1. Okay, so let's just complete these functions now. So we know that we want to perform binary search. So while S is less than equal to E, before writing this, let me complete the parameters. It is going to take integer nums, int target, int s comma int e. Okay, and for the latter one as well, it is going to say the same. So I'm going to do while s is less than equal to e. I'm going to perform binary search. Okay, I want to store the global answer, so I'm going to take int idx is equal to -1. So the reason for -1 is, so if the element is not found, we are going to return this as -1. Okay, let me calculate med. Int med is equal to s plus e minus s by 2. We want to find it using a safe way. Then I'm going to say if whatever is at array of mid, is it equal to target? If that is the case, then what I'm going to do is, since I want to find for the leftmost part, right? So the right side will not be needed for us. So what I can say is, I can say end is equal to mid -1. And before doing this, what I can say is, I can store the answer in a variable idx is equal to mid. I'll update the answer. Otherwise, there are two possibilities, that array of mid is greater than target. Okay, that means target is lying on the left side. Target is lying on the left side, it does not lie on the right side. So I can say is equal to mid -1 again. Otherwise, target lies on the right side. So I do mid +1. Okay, and at the end, I'm going to return whatever the idx is as my index. So the right side implementation is going to be the same, except few stuff. So instead of when I find the target, I have to still go on the right? If we found target, tail search right. In that case, what we can do is, we can say idx is equal to mid, and we want to search right side this time, right? We still want to go right side. So the left side will be eliminated. So s is equal to mid +1. Okay. So I have set indexes, call this function, gave start and ending index. I think this should be it. Let's just run this code out. Yeah, so it is not an array. Let me rename it nums. Let's run it again. Yeah, so it is accepted and all the basic base test case passes. Let's just submit it out. Yeah, so it beats 100% and the solution is accepted. Okay, so this function is actually pretty duplicated. As you can see, most of the function between these left and rightmost is almost same. Just this one line has changed, right? So what I can do is, I can create a variable that whenever I want to go left, that after finding the target on the left side, if I want to go left, then I'll just do it conditionally. So what I can do is, I can keep track of a variable called as boolean is left. Okay, and what I can do is, here I want to check if I want to go is left, then I'll perform some action. Okay, and instead of making these two separate things, let me copy this out, and I can just remove this function out. Okay, then if it is not left, then it was right, so I have to go right. In that case, s is equal to mid +1. So let me make the common function find index, and for when we are going left, at that time I'll trigger this out, and when we are going right, I'm going to say that we are going right, so is left will be false. So I hope that this will run. So let's just run it out. Okay, I've made a mistake. Let's go run it again. Yeah, so it passes the basic test cases. Let's submit it out. Yeah, so it beats 100%. So this is the most optimal solution for this. And what is the time complexity of this? The time complexity would be O of log n, since we are performing binary search. And what is the space complexity? Space complexity is going to be O of 1, since we are not using any extra space. So that is it for the video. If you like my content, you can follow my channel, you can subscribe my channel, Also have a link tree in my bio. You can follow me there as well. So see you guys in the next one. Bye.